Codex CLI patterns for AI coding are only useful when every run leaves receipts. That is the whole thesis. If the prompt does not end in a reviewable diff, a test result, and a reusable command pattern, it is not a workflow. It is terminal-shaped optimism. I'll prove that with a small Python change because Codex AI coding is good at scoped edits, not at being trusted blindly. Start with repo state, not with vibes. Git status -- short is empty. Good. That matters because a clean baseline is the first receipt. A lot of Codex AI programming demos skip this, then quietly mix agent edits with old local junk and call it productivity. I would reject that in code review. If I cannot tell what the agent changed, the tool has already failed. Here is where most people get it wrong. They hand Codex CLI a vague prompt like improve the app, refactor auth, or add a better dashboard, with no task boundary, no test command, and no diff budget. Then they act surprised when the tool wants to touch half the repo. I would not let Codex CLI edit the whole repo from a vague app-building prompt without a scoped task, tests, and a diff review. That is not automation. That is delegated confusion. So here is my narrow definition of good Codex CLI usage. 1 scoped task, 1 expected test command, 1 inspectable diff, 1 commit. That is the pattern for Codex CLI patterns for AI coding, agents, assistants, and developers. The prompt template is simple. Name the bug or refactor, name the files it may touch, name the test command, and define done as pass tests, then stop. Cole Madine's PRP framing is about fixing input quality. Same idea here, just stricter on output receipts. Now the useful example. I'm using Codex CLI on a small Python task because Codex CLI patterns for AI coding in Python are where this tool makes sense fast. The session log in receipts/Codex CLI patterns session.log shows the exact prompt and the exact edit trail. That log is not decoration. It is the receipt that answers later, what did the agent think it was doing? If your agent run is not logged, debugging the workflow gets stupid very quickly. For Codex AI coding, this is the sweet spot. A bounded bug fix or a tidy refactor where the diff is the contract. My ranked take is straightforward. Git over every coding agent because Git is the adult supervision layer. After that, for this exact pattern, I'd take Codex CLI over Cursor when terminal evidence matters, because Cursor is a stronger editor loop than a receipts loop. Claude Code is stronger on long context, but it still needs the same discipline. No tool escapes review. Next receipt, git diff -- stat. This is how you keep Codex CLI changes reviewable. I do not start by admiring the pros in the agent output. I start by asking, how many files changed, and is that number consistent with the prompt? If the task was fix one parser edge case, and the diff stat shows a tour through unrelated modules, stop there. That is one of the best answers to how do you keep Codex CLI changes reviewable? Small scope, then small diff, then inspection. Then inspect the actual patch. This is where Codex CLI patterns for AI coding example stops being a demo and starts being a workflow. Read the hunks. Check for hidden renames, accidental formatting churn, or invented abstractions nobody asked for. I would not accept a broad cleanup piggybacked onto a bug fix just because an agent felt ambitious. The fastest way to poison trust in AI coding is to let one prompt smuggle 5 unrelated edits into main. After diff review, verify the code. The receipt here is python-q, or the repo's equivalent command. This is the answer to how do you verify code written by Codex CLI? You do not verify it by rereading the prompt more slowly. You verify it with tests. If there are no tests, then the safe answer is not ship anyway. The safe answer is the repo is not ready for coding agents on this task. Missing tests is one of the cleanest reasons not to use Codex CLI for programming. Once the diff is reviewed and the tests pass, make the commit. The receipt is the final git commit-m Codex CLI scoped fix with receipts. A saved commit is what turns a one-off interaction into a reusable pattern. This is also why I do not buy the framing that Codex CLI should replace Cursor or Claude Code. Wrong question. The real question is, which tool best matches the boundary of the task? Codex CLI is good for scoped code changes when the diff is the contract. Cursor is great for a fast editor loop. Claude Code is better when context is large and tangled. None of them replace judgment. So should Codex CLI be used instead of Cursor or Claude Code? No. Use Codex CLI when you want a terminal-first, receipt-friendly workflow around a narrow task. Use Cursor when the interaction belongs inside the editor. Use Claude Code when the repo context is the real problem. Theo-style teardowns are good at showing tool personality. The missing piece is usually enforcement. I care less about which tool sounds smartest and more about which one leaves evidence I can review after coffee. Counter cases are simple. Do not use Codex CLI for unclear requirements, sweeping rewrites, missing tests, or architecture decisions disguised as implementation tasks. That is where people ask too much of the tool, then blame the tool for failing. Codex CLI patterns for AI coding assistants only hold up when the assignment is narrow enough to verify. If the boundary is fuzzy, the prompt will be fuzzy, the diff will sprawl, and the review cost will erase the speed gain. So the recap is blunt. Codex CLI patterns for AI coding only earn their keep under 3 conditions: scoped prompts, passing tests, and reviewed diffs. The final clean git status -- short, the saved session log, and the commit are the receipts that prove the run happened and stayed contained. If you want the exact pattern, receipts in the description. Comment with the task boundary where Codex CLI breaks down for you, or tell me which tool you want head-to-head next. Next time, I'd put this same receipt standard against a heavier, long-context agent and see who survives review.